In this video, we're going to review part of Chapter 6, starting with bonding in general and then focusing on ionic and metallic bonding. So first, atoms bond because they need to satisfy the octet rule, octet standing for 8. In the case of hydrogen, that's the exception, it needs a duet. Now with ionic bonding, that will be between metals and nonmetals, and a nonmetal which has a high electronegativity will be able to rip an electron away from a metal that typically will have a low ionization energy, and accordingly, the metal will achieve its octet by losing electrons, the nonmetal by gaining electrons. With covalent bonding, two nonmetals or metalloids having similar electronegativities, they will have to share electrons in order to satisfy their octets, and we can symbolize it accordingly. Metallic bonding is a different model. The model that we use is that there is a sea of delocalized valence electrons amid a whole lot of cations. So as we look here, we've got a bunch of zinc cations, and their valence electrons are delocalized. They don't belong to any particular atom or ion. This model for metallic bonding explains why metals are electrically conductive and why they're malleable. Next, we have network solids, which are huge covalent molecules. You can't really tell them from the molecular formula. However, if you see a very, very high melting point from a covalent compound, that typically indicates a network solid. Case in point, diamond, which melts at about 4,000 degrees Celsius. Now to focus on ionic bonding. All ionic compounds will form a crystal lattice structure. The crystal lattice is essentially one large crystal, The crystal lattice is essentially one large crystal, so we can't really talk about discrete molecules, so instead we refer to formula units when we discuss ionic bonding. Lattice energy is the energy that is released whenever ions come together. Another way of looking at it is that if you were to take all the ions in a crystal apart, then the opposite of that energy required to pull it apart would be the lattice energy. Lattice energy increases with increasing charge of the ions, so in the case of MgO, which is +2 and -2, that's going to have a greater lattice energy when compared to sodium chloride, which is a +1, -1. Also, lattice energy decreases with increasing size of the ions, so lithium chloride will have a higher lattice energy than cesium chloride because lithium is smaller than cesium. On now to Lewis structures of ionic compounds. So if we have potassium and sulfur, potassium has one valence electron and sulfur has 6. K needs to lose that valence electron, and sulfur needs to gain 2 valence electrons. So we can say that two potassium atoms each will give an electron to the sulfur becomes -2, the potassiums each are +1, and having satisfied the octets for all, we can say that the formula is K2S. That's all for this video. I hope it's been helpful. Feel free to leave any questions or comments in the comment section below, and thanks for watching.